How do we convert standard to vertex form? I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss how do we convert standard form to vertex form for a given quadratic equation. So standard form normally is y equals to ax squared plus bx plus c, and the vertex form is a x minus h whole square plus k. So when we say standard and vertex form, from the vertex form we get an advantage of finding the vertex. The graph shown here on the right hand side includes a vertex which is common to all the graphs shown here. The coordinates of this vertex is hk, right? Now, depending on the value of a, we have different kinds of parabolic family of curves with some very common vertex. So those which are opening up, for them the value of a is greater than 0, and for those which are opening down, the value of a is less than 0. Well, it could be different since we have different curves. But I hope you understand that very important point, the vertex itself, which gives you a maximum or a minimum value on a parabola, can be identified using vertex form of the equation, and that makes it very special, correct? Now you can see, in case the graph opens up, we have a minimum, right? But if it opens down, we have a maximum. So the vertex also gives you minimum and maximum value. Now the question is, how do we convert standard form to the vertex form? Well, some of you will need to review this perfect square formula, which is a plus b whole square, a square plus 2ab plus b square. Since we are talking about h and k, I changed this equation to x plus minus h whole square and wrote it as x square plus minus 2xh plus h square. We'll see how to use it. We'll take up many examples and consider maximum and minimum values from the vertex form. We'll also see the steps to convert standard to vertex form. And we'll take up examples where the value of a could be 1, minus 1, greater than 1, or less than, I should have written here, greater than 1 or less than minus 1. Okay. Let's say, better still, we'll say less than 0, negative number. Okay, so we'll consider different cases. That's what I mean. These are the questions which we are going to take to explain the whole concept. With each question, we'll follow the steps which will help us to convert standard to a vertex form. I'll discuss the general solution, general method of converting, but then first we will understand the solution of these examples and then get to the general method. Perfect. So that is where we are. In case you want to learn from me, you can always join my classes by sending an email to the address given. Most of my students are doing extremely well. Some are even getting awards, like Akshit.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Now, let's look into converting these equations which are given in standard form into vertex form. As you can see, coefficient of x is -1, 3, -half, and this is the general solution which I am going to provide at the end of the video. So the very first question here is y equals to x squared plus 6x plus 5. To write it in vertex form, what we really do is follow a few steps. Let me rewrite the question first. Y equals to x squared plus 6x plus 5, right? So what we do is x coefficient is 6. We find half of this number, square it, add and subtract. So what is half of 6? Half of 6 is 3. So we'll add 3 square and we'll subtract 3 square. So that is what we do to complete the squares. And rest the constant we're going to write as such plus 5. Now this is a very important step, and in fact it is giving the name completing the squares. I hope you remember the formula, which is what is a plus b whole square equals to. Now a plus b whole square is a square plus 2ab plus b square. Now in this expression you see we have b as 3, right? X as a. And the center term 6. You can get 6 by 2 times, 3 times and then x. You get the idea. And therefore these 3 terms can be written as what? They can be written as x plus 3. Let me write plus here. X plus 3 whole square. You get the idea. So basically, this trinomial can now be written as a perfect square. So let's do that. Write it as a perfect square. So we get here x plus 3 whole square. We're left with minus 3 square, which is minus 9 and plus 5. Now these constants can be added. So we have x plus 3 whole square minus 9 plus 5 gives me minus 4. So that is the vertex form. Now when you get this vertex form, since the coefficient is positive 1, we do get a parabola which opens up. So we have a parabola which opens up, and in this particular case, the vertex is what makes it 0? Minus 3, the x value. And if this is 0, you get minus 4. So that becomes the vertex. Since it opens up, we have absolute minimum of minus 4 at x equals to minus 3. Makes sense. So that is the information you get from here. Very critical information. Now this was simple. We just had x squared, no coefficients. In fact, 1 is a coefficient. Now here is a second example. Once we do 4 examples, you will understand this strategy. But you can now pause the video and try it out. So let us rewrite this question. Y equals to minus of x squared plus 8x minus 2. So what we really consider is these two numbers to factor. Any coefficient of x is factored out. So in this case, the coefficient is minus. So I'll take minus outside. So we get x squared minus 8x. And we'll keep this number minus 2 separate. You get the idea. Now, minus 8x. What is half of 8? 4, right? So we can write this as x squared minus 8x plus half of 8 is 4. We add its square and subtract its square. Minus 2. So that gives us, as we discussed earlier, these 3 terms gives us a perfect square. But this time it is a perfect square of x minus 4. The idea is that this negative comes here, right? So this negative, a minus b whole square, right? Whole square. And now this minus should also be multiplied by minus 4 square. You get the idea. So it is a good idea to not only use this bracket, it's better to use a square bracket here so that we avoid confusion. Many times, students forget to multiply minus with the other number. So do you see the square brackets? They help us to understand the concept better. So why we multiply minus with minus, we get plus, and square of 4 is 16. You get the idea. So we actually will open it next time. Let me just, since I put the brackets, let me write like this. So what we have done at this stage, formed a perfect square for this trinomial, and now we'll open the bracket. So we have minus x minus 4 whole square, and that minus times minus is plus 16 minus 2. So this gives you the vertex form combining the last two terms. We get minus x minus 4 whole square plus 14, correct? 16 minus 2. So we get a parabola this time which opens down. We are only focusing on the vertex and its importance. In this case, the vertex is at what makes this 0? 4, right? And plus 14 is the value. So 4 and 14. And this time it is the maximum of 14 at 4. So maximum value of y, right? You can also say the range of this function is less than 14. So with that, you understand something like what are we doing every time. So let's review the general solution since we have got some concept, right? Okay, so this is a general equation, ax squared plus bx plus c. So what we have done is we factored out a. So you factor out a. To factor a, we have to multiply b with 1 over a or divide by a, right? But keep the constant away. So what we did was we grouped the terms with x. So in the first step, group terms with x, right? And then you factor a. So that becomes the second step. So any coefficient of a, right? So that ensures within the brackets we have a with coefficient of 1. And then you do b by 2a. And then you add and subtract b by 2a whole square. And that forms a perfect square. And based on the given equation, we write that perfect square, right? And continue. So these are the critical steps. So that gives you x plus b by 2a whole square. Where that plus sign comes if this is plus, right? And minus b by 2a, which is the other term, will be treated as a constant and then further worked on. You get the idea of what we are doing, right? Let's continue with solution 3, which has something like this. So this time, we have the equation which is y equals to 3x squared minus 6x minus 7. So as I was saying, group the x's and factor coefficient of x, which is 3. So if I factor coefficient of x squared, which is 3, I get x squared here. Dividing 6 by 3, what do we get? Dividing 6 by 3, we get 2. We did not factor x. Do you see that? And now, what are we going to do? What is half of 2? Half of 2 is 1. So we'll add 1 square and we'll subtract 1 square, mainly to form a perfect square. That will ensure that we have x minus 1 whole square. This is the 3 terms. X, you can check your value, right? So basically, minus sign comes from here and this number b by 2a comes from there. And we do have the other minus 1 within the bracket minus 7. Open the bracket now. So we get x minus 1 whole square minus 3 minus 7. That gives you 3 times x minus 1 whole square minus 10. You get an idea. So in this case, the coefficient of x squared was greater than 1, correct? So in that case, you have to factor it out, as we did here. So we get a parabola which has a vertex at 1 minus 10, opens up, right? So we can sketch this parabola, which opens up, has a vertex at 1 and minus 10, which is also minimum value. This could also be written as absolute minimum value because there is nothing lower than this. So sometimes we use absolute minimum too. And as you know, the axis of symmetry is 1 and so many other things can be defined from this vertex form. So I hope this part is clear, right? So let us practice with one more example where we have this a not equal to 1. So this time we have y equals to minus half x squared minus 5x plus 3. Can you tell me what should be my next step? I have to factor the coefficient of x squared, which is minus half. And I should use square brackets to club in the first two terms. Well, we have x squared. What happens to minus 5? Minus and minus makes it plus, and you have to multiply by 2 to get 10x this time. Correct? So we have minus half x squared plus 10x as shown here. Well, you can see, if you open the bracket, you get what you had, correct? Open the bracket and check. You get the same answer, right? Okay, now follow the steps for completing the squares, which is, we have minus half outside, x squared plus 10x. What is half of 10? Half of 10 is 5. So add and subtract 5 squared, which gives you minus half. And the first three terms, x plus 5 whole square, minus 5 square is minus 25 plus 3. Open the bracket. So we have minus half x plus 5 whole square minus 25, minus and minus becomes plus 25 over 2 plus 3. You get the idea. And now combine the last two terms. So we get half, which is all y equals to minus half x plus 5 whole square and plus 25 by 2 plus 3. Take 2 common, right? So we get 25 plus 6. And that gives you minus half x plus 5 whole square plus 31 over 2. Makes sense? So this parabola minus half means it's going to open down, right? With the vertex at, can you tell me what makes that 0? Minus 5 and the maximum value 31 by 2. Right? So maximum. You see how we did completing the squares? So let's review all these steps once again. So we understood that we have to group only two terms, right? Factor out a. When you factor out a, you get b by ax. Then you have to add and subtract b by 2a, half of this value, squares. Once you do that, the first three terms form a perfect square and can be written as x plus b by 2a whole square. Then we have minus b square by 2a, which can be opened written as b square by 4a square. Now open the bracket, right? I prefer to use square brackets because, to avoid the confusion basically. And then you can combine the constants. As shown here. You get minus b square plus 4ac over 4a. Now that's a very important formula which you'll see in the next video. How do we find zeros from this given equation? So that could be our next step. So I hope these steps are clear. And now, once again, review what we did. So basically, we grouped the two terms with x. In this case, there was nothing to factor, so that step is not included here. But half of 6 was 3, square 3, and add and subtract, making a perfect square and getting the answer, you see. So that is how we actually converted the standard form into the vertex form. Finally, these are the steps which are generally followed for converting standard form to vertex form, right? Is this absolutely clear? Feel free to write your comments and suggestions. If you like and subscribe my videos, that'd be great. And if you want to learn from me, you can always send an email on the address given. Thanks for your time and all the best.